Assalamualaikum and hi everyone. In this video, I would like to present about the thermal degradation and chemical analysis of the recycled polypropylene PP using a TGA and FTIR.
Polypropylene (PP) is widely used to thermoplastic in various applications, contributing significantly to the generation of plastic waste. This increase in the waste has created a strong demand for effective recycling methods. Mechanical recycling is commonly adopted due to its simplicity and cost-effectiveness, and it involves the repeated melting of the polymer during the processing. However, repeated heating during the recycling can potentially influence the material properties of polypropylene. Mechanical recycling exposes polypropylene to repeated thermal stress, which may lead to the chain scission and oxidative degradation. As the number of recycling cycles increase, the thermal and chemical stability of the polypropylene may decrease, limiting its performance and reuse potential. Therefore, understanding the recycling limit of the polypropylene is crucial to ensure its suitability for reuse and subsequent applications. These objectives of this study are determine the thermal stability degradation of virgin polypropylene (VPP) and recycled polypropylene (RPP). This study also aimed to evaluate the effect of the recycling process on the thermal properties of the polypropylene across different recycling cycles by using a TGA. In addition, the chemical changes in the polypropylene structure due to the thermal processing are identified by using the FTIR.
This study investigates the effect of the repeated thermal processing on the virgin and recycled polypropylene using the TGA and the FTIR analysis. Virgin polypropylene granules about 20 grams were heated in a conventional oven at 200 to 220 degrees Celsius for 20 minutes until they fully melted to form a uniform sheet, labeled as the R1PP. After cooling, the sheet was cut into the small flakes and trimmed to the 5 to 10 milligrams. The remelting process was repeated under the same condition to obtain the R2PP and R3PP. This is simulating the multiple recycling cycles. All the samples were labeled and stored in a dry container. This study investigates the effect of the repeated thermal processing on the virgin and recycled polypropylene using the TGA and the FTIR analysis. Virgin polypropylene granules about 20 grams were heated in a conventional oven at 200 to 220 degrees Celsius for 20 minutes until the for thermal analysis, the TGA instrument was set up with a platinum pen and nitrogen push gas. Approximately 5 to 10 milligrams of each sample were heated from 30 to 700 degrees Celsius at the rate of 10 degrees Celsius per minute to study the thermal degradation behavior. For the chemical analysis, FTIR was conducted using an FTIR setup with a wave number range of 4,000 to 650 inverse centimeter to identify chemical changes caused by the repeated heating. For the chemical analysis, FTIR was conducted using an FTIR setup.
Visual observation is a simple but effective method to identify physical changes in a material after processing. This is particularly changes in a color that may occur due to thermal degradation during recycling. Figures show the visual appearance of polypropylene flakes after each recycling cycle. The virgin polypropylene, as well as the first recycled sample R1PP, exhibit a bright red color, indicating the minimal degradation after the first recycling process. After the second recycling cycles, R2PP appeared slightly darker in color. This color change suggests the onset of the thermal and oxidative degradation caused by repeated thermal exposure. In the third recycling cycles, R3PP showed the darkest burgundy color, indicating the more severe degradation. Overall, The progressive color darkening with the increasing recycling cycles demonstrate the cumulative effect of the thermal and oxidative degradation on the polypropylene. This visual change suggests the chemical alteration in the polymer structure due to the repeated thermal treatment. This is consistent with the observation reported in the previous study. Thermogravimetric analysis or TGA is used to evaluate the thermal stability and degradation behavior of polymer by measuring weight loss as a function of the temperature. Figures show the TGA and DTG curve of the virgin polypropylene and recycled polypropylene after 1, 2, and 3 recycling cycles. All the sample exhibit a single major degradation step, which is the characteristic of the polypropylene decomposition. The presence of the single DTG peak in all samples indicate the fundamental degradation mechanism remain unchanged despite repeated of the recycling. From Table 1, the on-site degradation temperature T onset of the virgin polypropylene is 418.73 degrees Celsius. Higher T onset values are observed for the R1pp and R2pp at 430.09 degrees Celsius and 440.64 degrees Celsius respectively. This increase suggests improved thermal stability after 1 to 2 recycling cycles, which can be attributed to the retention of the stabilizer or additive that delay the initiation of the thermal degradation. However, after the third recycling cycles, R3PP show a lower T onset of the 414.62 degrees Celsius. This decrease indicates stabilizer depletion and increased transition caused by excessive thermal processing, leading to the reduced thermal stability.
This section discusses the mass loss behavior and residual content of the virgin and recycled polypropylene based on the thermogravimetric analysis result. From the Table 1, the weight loss of the polypropylene varies with the number of recycling cycles. Recycled polypropylene show the weight loss value range from the 96.748% to 98.431%, with the highest weight loss observed for the R2PP and the lowest for the R3PP. This variation is mainly attributed to the transition and molecular weight reduction caused by the repeated thermal processing. As the polymer chain becomes shorter, they degrade more easily and volatile at a lower temperature. The residual content after degradation is low for the all sample. The range between 1.28 and 1.95 weight%. Virgin polypropylene showed a slightly higher residue value, which may be associated with the presence of the additive or pigment. In contrast, R3PP exhibits the lowest residue content. This is suggesting the further degradation or loss of the stabilizing component after excessive recycling. FTIR was used to identify the chemical changes in the polypropylene caused by the repeated recycling. The spectra of the virgin and recycled polypropylene were compared to observe the changes in the functional group. VPP showed a weak or the minimal absorption band corresponding to the CH stretching and bending. This is indicating a low presence of the aliphatic hydrocarbon. In contrast, recycled samples display the distinct CH stretching at around 2,920 per centimeter and CH bending at approximately 875 per centimeter. This is suggesting the formation of the introduction of the alkyl chain during the thermal processing. The carbon backbone also showed the changes. The C-C linkage band at approximately 1,170 per centimeter and the CH2-CH3 bending band around the 1,450 centimeter per centimeter are weak in virgin polypropylene but more prominent in the recycled samples. This indicates the structural modification and the development of the carbon-based backbone in the recycled material. A major distinction in the appearance of the carbonyl band around the 1,700 per centimeter. This band is absent or very weak in a virgin polypropylene but clearly present in a recycled sample indicated the oxidation, degradation, and crafting. These peaks suggest the formation of the oxygen-containing functional group such as ketone, ester, carboxylic acid, or amide due to the repeated thermal treatment. Overall, the FTIR analysis demonstrates that the repeated recycling introduced the chemical modification in a polypropylene. The increased intensity and emergence of the CH-CC double bond or absorption bands in recycled samples show the oxidative degradation and structural changes while the basic polymer backbone remained largely preserved. This study used the oven melting, TGA, and FTIR to assess the effect of the repeated thermal recycling on the polypropylene. TGA showed that virgin to the 3-time recycled PP degraded in a single step with the high weight loads. 1 and 2 recycling cycles slightly increased onset, peak, and end-set temperature, suggesting the stabilizer retained the thermal stability. After the third cycle, this temperature drop indicated the reduced stability due to the stabilizer loss and chain scission. FTIR confirmed the chemical changes with a stronger CH-CC and C-double-bond-O band in recycled PP, showing a new functional group form. Overall, PP can tolerate a few recycling cycles with a minimal degradation, but excessive recycling lower thermal stability.